Good evening, flippers. Our video is 3.13. Our unit title is Stop Motion Animation, and our objective today is I will be able to solve angle of depression and elevation problems using trig ratios. So the trig ratios we already learned, now we're going to apply them in word problems. Woo, you're excited. I am. So we need to know what angle of elevation and angle of depression means, and I will explain. So, the angle of elevation of an object is the angle between the horizontal, so for example, or horizontal could be the ground, and the line from the object to the observer's eye, or the line of sight. So if we're looking at a picture, because it's much easier to see this in a picture, I'm looking here, and this is the observer, and my angle is the angle right here, theta. And it is the angle created by my view to the object, so the object, and the horizontal that I'm standing on, which is my line of sight. And that's my angle there. Okay, so that's an angle of elevation. An angle of depression is not when you're depressed. It means when it is underneath or below the observer. So the angle of depression is the same as an angle of elevation, but this time the object is viewed is below the person viewing the object. So if I come down to the picture, okay, here's my angle of depression, and it is created by the horizontal that you are standing on, or that is coming out from the observer, and the line of sight to the object below. So as you can see, these are pretty similar. They're both angles, but they're a little different based on what you're looking at. So in these problems, continue with our notes for a little while. Even though we're using the vocabulary angle of depression and elevation, you still need to be using your trig ratios, because these angles of depression and elevation, well, they're just triangles, right? So we're still going to be using, for example, opposite over, for example, hypotenuse, to solve for some of these angles. So I think you should still write these down or refer back to these in earlier notes. Okay. So, our examples. 1. Is this an angle of depression or elevation? And what is the measure of our angle of depression or elevation? Well, for example, we know something is an angle of elevation or depression based on where the object is that the person is looking at. In this example right here, or I wrote example, our human or our viewer is looking at an object above them. So it's an example of an angle of elevation. So I'm going to write Ella for elevation. Here, in the example in our problem, we have a triangle, but this time instead of facing this way, instead of our person being over here on the left side of the triangle, our person's on the right side. But if we notice, they're still looking at an object above them. So, what do you think? Well, I think it is going to be an angle of elevation. Okay. So that's our angle of elevation. What is the measure of our angle? Well, I'm looking right here. Our only angle here, which we have identified already as our angle of elevation, is, I think that says 69. So our angle there is 69 degrees. Okay, so we're good. That's it. And sorry to correct that before I move on, because I realized when I did the math that 69 doesn't make sense. It's actually, it is actually supposed to be 6.9. So correct that. Make sure that it's correct on yours before we move on. So B, Solve for h, the height of our tree, which we see right here. And we know its height, right, because it's going up and down vertically. So as I look at that, I think about what I have been given and what is my unknown. What is my variable I am trying to solve? Well, my variable is h, right? And what I've been given is an angle, 6.9, and a side. Well, if I'm looking at my angle, I notice that this side here is touching it. It is adjacent to it. And I notice that my variable I'm trying to solve, h, is in fact opposite to it. So I have opposite and adjacent. What trig ratio will I use? Yes, with my handy dandy acronym, I know that I should use TOA, and that means I should use tangent equals opposite over adjacent, TOA. So I take that formula and I am going to plug in my givens here, here, and here to my formula. So I take my degree and I plug it in right here. And I take my opposite side, h, and I plug it in on the top because it's TOA, the O is first. And I take my adjacent side and I plug it into the bottom. So it mirrors exactly this formula here. But now it has our information that we need to solve for h. And now I use some algebra to solve. Well, I have 248 on the bottom. I want to get h by itself. I'm dividing h by 248. So to get rid of that, I'm going to multiply by 248. And I'm going to multiply by 248 on the other side, and I'll just show you what I get over here. I get 248 multiplied by tangent of 6.9 is equal to h. And that's what I get when I do my algebra. Now you need to go onto your graphing calculator and make sure that you do this problem with the parentheses around your 6.9 so that you get the correct answer. And if you do this, you should get something around 175.86 when we round to the nearest hundredth. Okay? Problem 2. Suppose a tree 50 feet in height casts a shadow of length 60 feet. What is the angle of elevation from the end of the shadow to the top of the tree with respect to the ground? Set up the problem by drawing the picture. Well, I know that it's 50 feet in height, so I've got my height right here, 50 feet, and the shadow casts 60 feet in length, so that's going to be how long the shadow is on the ground, so our horizontal. And then, so our last triangle is going to be from the top, or the last side is going to be from the top of this, of the tree, to the bottom of our shadow, and we connect those 2 points there, draw a triangle. What is the angle of elevation from the end of the shadow? So my angle is going to be right here, the end of my shadow, to the top of the tree. And that means it's an angle of elevation. So that's our picture. Now, for time's sake, I'm not going to actually solve this problem, and I'm going to let you get ahead to your secret hot question. Okay, so the secret hot question. You are standing 80 radical 3 feet away from a building that is 80 feet tall and looking at the top of the building. What is the angle of elevation from the ground where you're standing here to the top of the building here? So there's your diagram. This will help you. Remember to look at it. I'm going to go down. A, what trig ratio will you use to solve this problem? What trig ratio will you use? And B, well, solve the problem. Okay? Have a good evening, flippers. See you tomorrow.